Hi everyone. So uh, I want to record a video regarding uh, simple functions, introduction to Python and simple functions in Python programming language. This can be useful for people who don't know Python or they want to get started with Python or they want to review the Python concepts for the coding interviews. Okay, so but if you already know Python, I think it might not be that much useful for you. Mm, so let me start with saying that how we should work install Python and something like that. So first off, uh, usually for uh, when you are working as with different projects, you can work either I can say with Anaconda or with pip. So conda or anaconda uh, uh, and pip, they are two things that you can or install packages of Python using them. So now, but here now I'm gonna tell you how to do it with conda. So first off, let me share screen. So what we do, we go to anaconda, anaconda download or something, and then you can download Anaconda for your operating system. For example, mine is Windows, so you can uh, say Anaconda free download of Anaconda for Windows. You can also install for Linux, Mac OS, etc. So it has different versions also for different operating. So you can install Anaconda, and afterwards, I suggest that you install uh, install VSCode. So VSCode is short for Visual Studio Code. Visual Studio Code or VSCode. It's the free version of Visual Studio. Visual Studio itself is not free, but Visual Studio Code is free. And it is a meta platform for different programming languages. For example, you can use VS Code for Python, for Java, for C, C++, JavaScript, etc. Here we are gonna use it for Python, and also note that there are two. So these platforms that you can code in are usually also called IDE. So there are at least two important IDEs for Python programming, I can say. One of them is VS Code, the other one is PyCharm. So I think PyCharm is PyCharm, yes. Uh, Here is a PyCharm. However, I think I have worked with both. I believe that VS Code is a bit better, at least in my taste. So it's and also I've seen that in industry, people usually use VS Code. So anyways, when you install Anaconda and then you install VS Code, then as far as I remember, uh, VS Code finds Anaconda. So while you're installing VS Code, uh, knows that you have already installed Anaconda, and then what happens? And then let me share a screen of how we should. Uh, yes. So after you install Anaconda and VS Code, you go to Anaconda prompt. So it is a terminal for Anaconda, and then you can have different conda env list. So there are several important comments that you can use in this Anaconda prompt. One of them is conda env list. So they usually start with conda, which is short for Anaconda, and conda env list, what does it do? So env is short for environment, and list lists them. By the way, Anaconda works like this. It makes several environments. So Python is like that. We have Python environments where in each environment you install your packages. Why do we have several environments? Because we might want to use one environment for one project and another environment for another project. And sometimes we want to use different packages for the different projects. And sometimes these packages might be conflicting. Therefore, we do this. We can have several ones, and then just for example here I can see my environment lists. If I want to make a new environment, then I myself don't memorize many of the uh, commands, so I look them up a lot. So conda make or create new environment. Create new environment. We go to this website. And as you see here, I think a little bit above, yeah, conda create, no, this, no. Let me find it. Where was that? Oh, it's here. Yes, conda create dash dash name my env. So for example, here I say conda create dash dash name, and this here I put the name of the environment that I want, something like test. And then I can have this. So I go to conda create dash dash name test or tutorial. Let me name it tutorial. Tutorial. Uh, so now it asks me, are you sure you want to proceed or not? If I say yes, Y or nothing means yes, and N means no here. When this is, the Y is in the brackets, so it means that if you also say nothing, it means Y by default. So you enter, and then it has made the tutorial now. Now I use conda env list to see my environments and what the tutorial has been made, as you see here. So now I'm in the base environment. We have also base environment. Now I don't want to be in the base environment. So let me go to the tutorial environment. So I say conda activate tutorial. Now when I do that, I go to the tutorial environment. Now inside each environment, I can also see the installed packages. So I say conda list. So see the difference between this and the previous comment. The previous comment was conda env list, which lists the environments. This one, it says conda list, which lists the packages in the environment that you are activated in. So here conda list, here it shows nothing because we haven't yet installed anything in it. So here we go and say whenever I want to install a package, I Google it. For example, conda install. Let's say numpy. So then we usually have uh, the commands listed in the anaconda.org. So we go inside that, and then here we have conda install. So we copy the command, and inside the activated uh, environment, now I'm gonna install numpy. Now it asks me whether you want to proceed, and for installing numpy, it needs to install some other packages as well, where numpy depends on them. So I say yes, proceed. Now it tries to install them in the environment. Now I use the previous command conda list to see the installed packages. Now I see that these have been installed, and this is the version of these packages because uh, as you know, we have different versions of the packages because they are keep developing them. Uh, Now here, for example, numpy has been installed with a version 1.23.5. Okay, by the way, assume you want to install some package and you Google it and you'll see that it doesn't have an Anaconda package. Or uh, when you install the Anaconda package, it gives you some error, maybe conflicts of the packages, something like that. In that case, then we go to plan B. And what is the plan B? For example, I tried to install numpy and it didn't work. For example, numpy is an example. And then I say pip install that package, the name of that package, for here, numpy. And then I go to the numpy.org and get the command line. And here, then I say install using pip. So when you are working with Anaconda, the best thing that is that you install packages with numpy. Sorry, you install packages with Anaconda or conda. But if it doesn't work, if it gives you error, if it gives you conflicting errors or whatever, then plan B is installing them with pip. However, some people don't work with Anaconda, especially in industry. Many people, especially who code Python in Linux, they usually don't work with Anaconda. They install everything and they work with pip. So they work with VSCode, but not with Anaconda. With pip, they usually. So in that case, they always install their packages using pip only. However, here, now that we are using Anaconda, we install using Anaconda unless it's not possible, and then we go to pip. So that's one thing. Okay. And by the way, you can also specify the version. For example, pip install conda. I think we need to say equal then the version. For example, 1.23.5, something like that. And then it will install that version. Don't memorize anything. Always Google that. For example, I say I want to install. So pip install numpy version 120, as you see, and then we go, for example, oh, this is the because here is the command line, as you see, pip install numpy equal 122, and also there are some description of what this variant has compared to the previous versions. Okay, so that's one thing. And now let's move on to what? Let's move on to yes. Let's move on to VS Code. So now either I type VS Code or a better thing is that go to the folder that you want to have the code in. For example, here I want to have the code here in the folder Python tutorial. Then I copy the path. Here I say change directory. CD is short for is the Linux command for change directory to this path. Wait, here I was in C. I wanted also to go to a subfolder in C. In Windows, I'm saying that drive C. If I wanted to go to another drive, here in my computer I have only one drive. Assume you have a drive D, for example, then you have to change directory might not work initially. Then you say D, then colon. Then you enter it, it goes to drive D, and then you use the change directory. That's one thing that you should note. Okay, now I'm in the path, and then I say code. Some of you guys who know a bit about these things, you might be wondering, why do we need to change the directory here? Because if you don't know, sometimes it gives you the Python interpreter cannot find the path easily. So that's the reason. Okay, it doesn't matter. So we go, it's better to change the directory here, and then we say code, and then enter. The code by default opens the VS Code. Okay, here we are. Then if you have had coded beforehand in another folder, it will always show the previous folder that was opened beforehand. Then you go to file, you go to open folder, and then you find the where is that? Let me find it. Tutor Python. Yeah, Python tutorial. You find the folder and then you select the folder. Okay, doesn't matter. Here we are now. Uh, so as I said, you open the folder. So you have in file, open folder. Open file only opens a file, like .py file. However, you need to go to the folder that you want to work with, and that's the open folder. Okay, now what do we do? Here we are in the folder that we want to. Now I right click on this side and say new file. Then I, for example, make main.py. So to specify the format of the file here, for example, .py, right? So main.py is here. And now I have the tabs here which show the files that I'm open. Let me open another file, for example, I don't know, f1.py, assume. And then what happens? So when I click once on the file, it will, the tab will be italic. What does it mean? It means that if I go to this file again, after a while, this tab might not stand here. But if I want the tab to be standing here, I need to double click on it. So now it's not italic anymore. Another thing is that, okay, let's go to the, by the way, I can delete the files like this. Here I right click on this, then delete the file, or I can rename it test.py, right? Now let me delete it. Yes. Okay, so I have this. Now what do we do? Let's start with some fundamentals of Python. Yes. Okay, so first off, what do we do? Let's start with the data types uh, in Python. Give me a second. Okay. So there are several data types or data structures in Python. One of them is list. So here, by the way, comments in Python is with hashtag. So here, control number 3, sorry, shift number 3 gives you the comment, right? So I write things. By the way, I might have several lines of code, for example, and I want to comment them out. So I select the lines and then I use the uh, hashtag or shift 3. No, sorry. Um, sorry, I made a mistake here. So I can make a comment here. So shift 3, which is the hashtag. I write things, but however, if I want to select several lines and comment them out, I need to use the control slash. Control slash comments them out. If you want to uncomment them, control slash again. So I'm using control slash again. So that's one thing. This is for comment. Now consider this. So list is like this. So it's just an array. So for array, we have at least 2 data structures in Python. You can see it as also maybe linked list. So what is this? So list is the simplest one. List is this. For example, A is a list of 1, 2, 3, 2, right? So and also have a for loop over them. So I can say for I in A, print I. What does it mean? For every element in the list A, go one by one in them and then print them, right? I also can have A index. So for example, what is A0? It's 1. It is A2, it's 3. Why? Because indexing in Python starts with 0. It's not like MATLAB, which just starts with 1. So it's zero indexing, zero-based indexing. So here, when I say A0, it means 1 here. A1 means 2, etc. Right? And by the way, the last one is A minus 1, which is the last one. A minus 2, which means the second last one, something like that, which is 3, right? And also, when I have, so let me go one by one. Uh, so here I comment this out. Now let me run this. By the way, before running, I need to tell you this, that in VS Code, before running, you need to select the interpreter. What do by interpreter? The environment that you are working with. So the shortcut for that is Control Shift P. So use select Control Shift P. You click on them, and it gives you several options. So then you type there. Let me see if I can move these things. Yes, here. So what am I doing? Control Shift P. Then I'm typing select interpreter. Select interpreter. It brings you this option, the Python colon select interpreter. I choose this, and then it brings me all of the environments that are I already made. Do you remember I made the environment of tutorial? Okay, so now I choose the environment tutorial. Now it recognizes all of the packages that I have installed in that environment. So here, what do I do? Let me run this thing. So for running, there are several options, by the way. Here we have run Python file. We have run Python file. In dedicated terminal, we have debug Python file. So we can run it in debug mode, or we can run it without debug mode. We can also run this from this part. So here in the top, we have run. You can say start debugging or run without debugging. F5, Control F5. So uh, if you use F5, that's a shortcut for debugging. Here I use F5. By the way, there is a difference between debugging and not debugging. For debugging, you can have a bullet breakpoint, and then so here do you see this? My cursor. I can put the breakpoints anywhere that I want, and then when I say F5 or debug, it comes and runs, and it will stop here. Stop here. Now I can go to my here below. I have several tabs, right? Terminal is a terminal that it ran, and but I have debug console. Then I can see A here, and I can do anything with it here. So you can see debug console similar to the command line of MATLAB if you already have worked with MATLAB. And here this code is similar to M file of MATLAB, but debug console is like command line of MATLAB. Anyway, by the way, I believe, as far as I remember, for debug, for using debug and debug console and debug mode in Python, you have to install it in the VS Code. So VS Code has some extensions. Here in the left side, do you see here? I have extensions. I click on that, and then I install Python. So you have to install Python. I already have installed it. So I typed Python in the extensions and I already installed it. Otherwise, you will see install here, you install it. That's one thing. I think in addition to Python, you have to install Python for this to recognize the Python and Anaconda. And in addition to that, I think you have to, as far as I remember, debugger, Python debugger. Or I might be wrong. I don't remember. It has been a while. Maybe the moment that you install the Python here, it also installs the debugger by default. Uh, anyway, so you have to install this. I forgot to mention this step also. So now here, I'm here. I ran the code here. I can go line by line in the debug mode. You can see my cursor here. If I say continue, it will go until the next breakpoint. If I say step over, it will go to the next line in the code. Then I can say step into, for example, this line might be a function which I'm calling. Then I can say go inside the function, the next line in the function. If I say step over, it says that run the function, don't go inside that, and then go to the line after the function. So this is the difference between these two. And also I can stop the program by clicking on this. So anyway, so here I stop it. There is a command in Python named pass. Why do we need this pass? There are several reasons. First off, Python works with tabs. Okay, what do I mean by working with tabs? I mean this. Uh, just give me a sec. I mean this. For I in A, such as there. Now if you have worked with other languages, for example, some of the languages such as C, they work with accolades, right? Something like that. But here in Python, we don't have any accolades. We work with only tabs. So for while, for if, and these things, we have to go one tab or indent. Now I say I need to have some comment. For example, I don't know, I equals I plus 2, right? However, you should note one thing. What if sometimes I have the for loop and I want to implement it later, but I don't have any command in the for loop. So if I leave it like this, it will give me some error. It says that in the tab, you have to have something. However, you can say pass. Then it will not give you an error. So it means that do nothing in this for loop. That's one use case of pass. Another use case of pass is this, that you want to, in the debug mode, you want to put a breakpoint and you don't want to put the breakpoint here. Why? Because you want to run this also, but after this you don't have any command in your code. Therefore, you put a pass here and then you put the breakpoint here. Okay. So I already said the use of pass also. Now I'm here. So let's see. We go to debug mode, debug console. By the way, you should note that we have several terminals here. We can have several terminals here. So here it is Python debug console. As you see, I can add a new terminal, right? So there are several options for the terminal. So I have PowerShell terminal. What is PowerShell? The regular terminal that we can run the codes in. We have Git bash terminal. If you install Git in your operating system, then this appears that sometimes you want to work with Git, right? We can have a command prompt also. We can split the terminals vertically, horizontally, and these things here. Doesn't matter. Let's go to debug console. And now I can see my A here in the memory. Did it print I? So the prints and all of them come to the terminal. I believe it works. Yeah, here it is. So 1, 2, 3, 2. It went over the elements of A and it printed them. And what is A minus 2? Let's see them one by one. Is 3, as I said before. What is A0? It's 1. Okay, now what is append? So when we're working with list, we can append to that. So it appends an element to the end of the list. So when I say, for example, 5, now A becomes 1, 2, 3, 2, 5. What is extend? There is a difference between append and extend. Extend extends the list, however, its input should be a list. So, for example, A is the list, right? 1, 2, 3, 2, 5 here. Now I say extend it to 4 and 8, right? So what happens? Now let's see A. It became 1, 2, 3, 2, 5, 4, 8. What if I want to add a 9 to it? There are two ways to do that. Either I say extend the list of 9, right? Or I say append 9. Without list. Now it appended a 9 to that, right? That's one thing. Now also we can pop things. So what do I mean by this? Pop, I say a pop. It gives me the last element, I guess. Yes. So here now I print A. As you see, it returns the last element of the list A, and also it eliminates that from the list, as you see here. So let me do it again. A pop. Let's see A. See, 9 went out of. If you do it again, 8 goes away. Okay. What if I say I want to specify which element I want it to be popped? So for example, here I want the element, the one to the last element to be popped. So what index does it have? 0, 1, 2, 3, 4. 4. A4 is 5, right? I want to pop A4 and also eliminate it. So let's do that. Then I input 4 to the pop. It gives me 5, and also it has been eliminated from the list. That's one thing. Okay, that was list. That was list. Now we go to the next data structure in Python. And what is that? That's a tuple. But before tuple, let me explain numpy array as well. I think numpy array is more related to list. So also we have numpy array. What is numpy array? It's like this. Let me see if I have some example in my computer. Okay, that doesn't matter. I can make some examples right now. So let me stop a program. Let me think. Okay, so you say A is NP. You need to import, by the way, import numpy as NP. So what is import? Import is like means importing or using the packages, right? So I have I do remember I installed the package numpy, and now I'm gonna use that. But you might be wondering, why didn't we import anything for list? Because there are some things which are automatically already imported or used in I can say they are default in Python. And there are such things such as list, dictionary, tuple, these things which I will introduce to you. But NumPy is not one of them like that. It's not imported by default. So you have to import them. And therefore you use import NumPy. You can say this, import NumPy. However, NumPy is big. Usually when the names of the packages is big, we can shorten them or we can change the name. So I can say import NumPy as Benjamin, as Ben, whatever. Usually it's by convention, import it as they rename it to NP. Import numpy as NP. Okay. So when you say as something, it means that rename it to that thing. Okay, that's one thing. Also, for importing, let me tell you one thing. So maybe you have a package that you want to import something from it, not the whole thing. So you can say, for example, from numpy import. I don't know if, yeah, I think sort. For example, sort is one of the functions in the package numpy. Okay, I don't want to import the whole numpy package, only the sort of it. Then I can do that. Usually for big packages like numpy, for famous packages, they don't do this. It's not recommended to do this in coding for numpy, for at least. But usually, when sometimes you have your own classes, which we'll see, or your own .py codes, and then you don't want to import the whole class or the whole .py code from your own code in this code. Then you say from my other code only import some specific function. Then in this case, this is used a lot. However, I'm saying that for well-known packages such as numpy, it's not recommended to do this. But I want to tell you how you can import things. That's why I'm explaining this. So one way is import the whole thing, import, for example, numpy or numpy as np. It imports the whole numpy. Another way is that from numpy only import something. Also, you can change the name. So, for example, from numpy import sort, but name it as Benjamin. So whenever I say Benjamin in code now, it means sort of numpy. Okay, that's another thing. So now I have import numpy as np. Then I say a equals np array. Then I can say, so as the input of np array, you need to feed a list or a list of lists or a list of lists of lists or something, etc. Right? So if I input the np.array a list, for example, 1, 8, 5.6, something like that. What will it give me? It gives me a one-dimensional row vector of 13856.6. What if I say this? A list of lists. Of course, for example, a list of two lists with the same length. The length of the list should be the same. For example, 4, 3, 6, 1, 2, 3, 4, yeah. Then what happens? It gives you a matrix of with 2 rows and 4 columns. The first row will be this, and the second row will be this. You can also have rank 3 10. Doing what? By adding another level of list, something like that, right? So that's one thing. As you understood, I think numpy array is used for making vectors and matrices and tensors in Python. So let's take a look at them, for example. I need to put a pass here for the breakpoint. So when I have this is my one-dimensional vector, right? Row, sorry, 4-dimensional row vector. Now let me have this. It becomes a matrix now, as I said. Okay. Suppose A, for example, A dot T, capital T, A dot capital T is short for numpy dot transpose. Okay. So it transposes that. Again, I can transpose it back. It becomes the same, right? That's one thing. important for NumPy. Another thing is that shape. A, for example, A is this, right? A dot shape gives me the size of this matrix or vector or whatever. Here is 2 by 4. It means 2 rows, 4 columns, right? If I have this, then its shape becomes what? Can you guess? You might be saying it will be 1 by 4, but it will not be 1 by 4 because it is only a row vector. Then it will stay only 4 comma nothing. It means that only 4-dimensional vector. It means that. So let's see. It gives you this. Okay. What if I want it to become 1 by 4? For that, I have to do this. You see, I make it a matrix with only 1 row. Then A dot shape becomes 1 by 4. That's one thing. Another thing is, let me think. Okay, I can have matrix multiplications. There are several functions you can take a look at. So I think one of them is np dot. I'm typing it here. Also, another one might be np dot. Let me check it up because, as I said, you don't need to memorize all of the functions. Np multiply. So one of them is np.multiply. The other one is np.matmul. There are a lot of things, but actually, my suggestion is that you don't use them. So why do we have several functions for np for multiplication of NumPy arrays? There are several reasons, because you can multiply matrices and vectors in different ways. You can multiply them element-wise. In mathematics, it's usually called Hadamard product. You can have Hadamard product, or you can have matrix multiplication, which is not element-wise multiplication. So you have several things. For each of them, there is some function, and you don't have to memorize them, right? Unless you are doing a coding interview. You don't have to memorize them. For example, you forgot and you Google it, NumPy multiplication element-wise. It gives you the function. You can also ask ChatGPT for that. However, here I want to give you a good technique for matrix multiplications. So when you are doing for element-wise multiplication, just let me Google it because I haven't memorized it. Element-wise multiplication, NumPy element-wise multiplication. I think it's np.multiply as far as I'm seeing now. Let's try it. So here, let's have this A. Also, let B be the same as A but times 3. So B is A, but each of its elements is times multiplied by a scalar 3. Right? When it is multiplication by a scalar, you can use the simple star, which is the multiplication. But when it is between two matrices or two NumPy arrays, then you might not be able to use the simple star. Doesn't matter. Okay, now we have A, we have B, these two. What do? We can have, I think, NP. Let me see. Just give me a second. Yes, NP dot multiply A and B. So what does it do? It multiplies them element-wise. Now another thing is that I want to have matrix multiplication. So what is the shape of A? Is 2 by 4. What is the shape of B? Is also 2 by 4. What is the shape of B transpose? Is 4 by 2. So I can have A times B transpose. Do you agree? So A is 2 by 4, B transpose is 4 by 2. So A, B transpose becomes 2 by 2. But how can I multiply them? Simple. There are several ways to do that. The simplest thing is using at sign. So at sign is matrix multiplication. A at sign. It does that. As you see, it became 2 by 2. I think there is another way, which is this. You use dot, and that, so there are several ways. You can say either np dot a b transpose is the same. You can also do this. You can say a dot dot the other thing, the same. For example, now assume I have several matrices multiplied by each other back to back. For example, let me think. So A is, give me a second. So I make it C, which is 2 by 2. So I have A, which is 2 by 4. I have B transpose, which is 4 by 2. I have C, which is 2 by 2. Therefore, I can say, I can have C times A times B transpose. I mean matrix multiplication. So I can C at sign A at sign B transpose. Do you agree? Right? Here, so I could do that. Another way to do this is this. NP dot between C and A, and then again doing NP dot between the result and B transpose. The same. Another way is this. C dot A, then again dot B transpose. So C dot A dot C dot A dot B transpose. That also works. But I think, as you see, the simplest among them is using at sign. C at sign A at sign B transpose. And that does that. Okay. This is for using Python for linear algebra. Okay. Now let's move on to the next thing. And what is that? Oh, by the way, so I told you the shape. The shape doesn't work for list. So assume I make it list D4, 5, 6. Can I have D dot shape? No, it gives me error, right? For list, you need to use len, which is short for length. So len of D or length of D is 3, all right? Len also can be used for numpy array. So you can have len of A, but what does it do? So what is A? 2 by 4. As far as I know, I might be wrong, but I think the len of a numpy array gives you the first shape. So it's A is 2 by 4. Now len of A became 2. Okay. So it's safer not to use length for numpy array, but use shape. But for list, you have to use length. Okay. That's another thing. Also, you can cast. What do I mean by casting? I can make a list numpy array and vice versa. Converting a data type to another data type is called casting in programming languages. So I can cast a list to a numpy array. For example, D was a list, right? I can say np dot array D. It gives me a list. I can put it in a variable named E, for example. E became a list of a numpy array of D, right? So D is list. However, E is its numpy array version. So there are two ways to cast list to numpy array. One of them is np dot array D. Another one is np dot as array D. They are the same. They are the same. np dot array, that thing, or np dot as array, that thing. Okay, so that was a numpy array. Now, what do we have? Just give me a second to. Okay, here now let's move on to the next data. structure in Python, and that's a tuple. That's the tuple. Let me stop the thing. Yeah. So tuple is this. So do you see the difference of tuple? Here, for least, we had A equal 1, 2, 3, 2, for example, with brackets. Here, for tuple, we use parentheses. Okay, that's a difference. So there are several differences between tuple and list. First off, tuple is immutable or unchangeable. You can't change it. Okay, so once you define A to be this, you can't change its elements, right? But list, you can change it. For example, um, let me put a breakpoint here. Let me run it. So here A is a list. Here A is a list, right? I can change, for example, the first element of A to be 5, right? And I can do that. It became 5, 2, 3, 2. However, when it is tuple, I can't do that. So let's now define A to be the tuple. So what is this now? Can I say A, this first element should be changed to 5? No, it gives me error. It gives me error. Okay, so now I can also go through the elements of the A and print them one by one. So what do we have here? Okay, here we have, however, one thing, we can concatenate or slice them to form new tuples. So you can have the tuple, but you can make new tuples out of it. You can't change that tuple itself, but you can make new tuples. For example, A is 1, 2, 3. A is this. And then I can say A plus 4, 5, 6 with the same length. Then what does it do? No, not with the same length, sorry. Then I say A plus 4, 5, 6. What does it do? It adds to the end of the tuple. So it was 1, 2, 3. Then it will append 4, 5, 6 to it. So for example, if I say 4, 5 only, what does it do? It was 1, 2, 3. Then it appended 4 and 5. So as you see, for list, we usually use append, but for tuple, here we use plus. I think, as far as I remember, even plus works for list as well. Let me try it. So A is now is a list. Can I say A plus the list 5 and 6? Yes. The plus also works for the list as well, for appending. So here we can also slice it. What does it do? B1 until so I can say, for example, 1 until 3. What does it do? So this means 1 until 3, right? So what are the elements here? Sorry, A. What are the elements of A? It is 1, 2, 3. Just let me define A here again, because I think I replaced it with a list. So A is this now. 1, 2, 3, 2. What does A 1 until 3 mean? It means take the, so these are the elements of A. A0 is 1, A1 is 2, A2 is 3, and A3 is 2, right? 1 until 3 means that A0 and A2. Note that the last element is never counted. So when I say 1 to 3, it means that gets A1 until A2. When I say A, for example, assume I say I have a very lengthy A, and then I say A until 1000. What does it do? It takes A10, A11, A12 until 999, right? Okay, so here, for example, when I say one until 3, then it gives me 2 and 3. Why? Because A1 is 2, A2 is 3, but A3 is not counted, is not brought. Uh, Also, you can use this indexing for various data types. It's not just for the tuple. For example, for numpy array, for the list, let's define list. A is this. Now I can say 1, 2, 3. That also gives me the list of two, A1 and A2. When it is a tuple, it returns a tuple. When it is a list, it returns a list, right? Also, you can have the you can use that for numpy array. For example, let me see, 3, 4, 5, for example. A is the, so I need to import it, sorry. Import numpy as np, and then this, I have A as this. Now, as it is only one rank 1 array, right? And then I can say 1, 2, 3. It gives me the array of 4 and 5 here, right? But what if here my numpy array was a matrix, so it had rows and columns? Let me make one. Then for indexing that, I have to use this. For example, I can say, you tell me if I say 1 and 2, what does it mean? Give me A1, the row 1, what does it mean? Remember that everything starts with 0. So row 1 means the second row, right? Because the first row is row 0. Row 1 is the second row, and column 2 means the third column, right? Therefore, it means that it should return 7, and it does that. Because the second row and third column element is this. But what if I want to get a slice of it? For example, I say second row, however, the columns 2 and 3. And because it's 0 indexed, I should say, let me think. Oh, yes. Do you remember? When I say 1 and 2, when 1 until 2, it means that don't count 2. So only return the column 1. However, I should say 3 here. Then what does it mean? 1 until 3, don't count 3. So 1 and 2. So it means that here, it means row 1, columns 1 and 2. So it gives me a slice of it, right? So let's make a little bit bigger. I want you to see the slices better. So A is this now. Assume I want to get, I don't know, let's see, for example, 8, 7, 80, 70, okay? Then I should say what? A rows 1 and 2. When I say rows 1 and 2, I mean second and third rows, okay? Rows 1 and 2, so I should say 1 until 3, right? When I say 1 until 3, 3 is not counted. So 1 and 2. And also, I need the columns 1 and 2, right? So I should say 1 until 3. So it returned 8, 7. This is slice of the A. You can also practice. For example, what if I want second and third rows and all columns? So when I say all columns, I should use this. This means all columns, right? And it gives me a second and third row, right? Row. What if I say all rows, but only the second column or column 1. It gives me exactly 4, 8, 85, but in this way. What if I don't want it to become rank 1? I want it to be again like this, a column. Then I have to use reshape -1 and 1. What does it mean? This reshape is used for numpy. What does it mean? It means that reshape it so it becomes only one column and whatever rows. How can it calculate this? Because the number of rows times the number of columns should equal the total elements, right? Therefore, Python can calculate it itself. So I can say whatever rows, -1 it means whatever rows, and 1 column. And if you do that, it gives you the column. Okay, back to tuple. Sorry, I jumped to numpy and list again because I needed to say some other things. Now back to tuple. So as I said, it's immutable. However, you can slice it and you can, or you can add something to it and put it in another tuple, right? I showed you some examples here. Okay. Okay. Now let's continue with the next data structure, which is dictionary. So, by the way, for appearing this debug console or terminal and disappearing it, you can use Control J. Control J brings it and also disappears it. That's a shortcut in VS Code, Control J. Okay, so here it is, dictionary. Uh, yeah, okay. So what is it? It's this. Dictionary, it is a hash table. So I think if you have passed any data structure course, you know that what hash table is. So in simple words, when you have a lookup table, assume you have a lookup table with some query ID, some keys and some items. Okay, so you have a lookup table whose first column, for example, are the keys, and also there are some items. So per each key, we have some item or some value. And then uh, assume I want to say for what is the value I want to search. What is the value of some specific key? So I say some key, for example, Jack, whatever. So assume that the keys are the names of the people. So I say the key Jack. So it go one way to uh, retrieve or return the value corresponded to Jack is to go one row at a time and search for Jack in the keys one by one, right? In the rows. So that's one thing. Of course, the time complexity is awful. Well, what if we have too many keys or too many rows in this table, lookup table? So people in algorithm try to design some algorithm which uh, accelerates the search in the lookup table, and that's called hash table. Using hash table, we can efficiently find the key and its corresponding value in the lookup table, and its time complexity is very efficient. Okay, that's called hash table. It uses hash functions. A hash table, also known as hash map or dictionary. It is a data structure that implements a set abstract data type, a structure that can map keys to values, as I told you. A hash table uses a hash function to compute an index, also called the hash code, into an array of buckets or slots from which the desired value can be found. So for more information, you can take a look at the courses on data structures, or you can just search it on YouTube. What is hash table? Okay, during lookup, the key is hashed and the resulting hash indicates where the corresponding value is stored. So that's an introduction to hash table. But anyways, dictionary in Python implements hash table. So it's a hash table. So it's query retrieval or finding the keys in the table is very fast. Okay. And here I have some example of a dictionary. For example, I have a dictionary. The name for dictionary you need to define it in this way. So with accolades, and inside the accolades you have key, then colon, then the value, then comma, then the next key, colon, sorry, the next key, then the colon, and then the value. As you see, keys are usually strings. So at least in practice, people usually use the strings for the keys. The values can be different. The value can be a string. The value here it is an integer. The value can be time. For this to be recognized, I need to import time. Time. The value can be a list. The value can be another dictionary. So you can have a dictionary inside a dictionary, right? It can be tuple, it can be numpy array, whatever. So here I have defined a as a dictionary here. Let me run it. So let's take a look at a. Here it is. Also, sometimes people, for making it cleaner, they define the dictionary like this. Like this. Doesn't matter. It's the same. Okay. And then we can iterate on the dictionary and read the keys and values like this. For key and value in a, which was the dictionary dot items, it gives me key and value and I can print them like this. All right. Also, we can do it in another way. For key and value in a dot iter items. So the difference of this and the previous one is that it was a dot items and this is a dot iter items. Iter short for iteration or iterate over items. This okay. The iter items, however, it was in Python 2. In Python 3, items has been replaced by iter items. What is the difference between these two? I'll tell you. So iter items was in Python 2, it was a generator. I will talk to you about generator a bit later. But items was not a generator. So a dot items would return the whole thing previously in Python 2, the whole dictionary, and so it was bad for memory, specifically if the dictionary was too big. However, iter items returns them one by one as a generator. So then they said that items doesn't make sense in Python 2 because it's very awful for memory space. So they simply replaced items with iter items and they deprecated the iter items. Doesn't matter. Nowadays we use in Python 3 we use items, which is items in Python 3 is a generator. Okay, so we have this. I told you about this, and what about this? So okay, we can return the value of a specific key like this. The here it is, name John, right? We can also return all of the keys like this, a dot keys, or a dot values returns the whole values. A dot get name, it also returns. So what does it do? A dot get name is the same as a name. It gives you the name, the value of name, which was John. We can have an empty dictionary like this. A is an empty now. We can define the dictionary in several ways. So one of them was this that I told you, like this. Another one using accolades. Another one is this. So The same thing, just give me a second, yes. The same thing, but we can have dict, short for dictionary, right? That's the same. We can also have, rather than, when we are using dict, rather than accolades, we can use brackets. So what does it mean? What is it doing? It's actually having a list, but it is casting it to a dictionary. Sorry for this. I apologize. When it is a list, it shouldn't be like this. It should be tuples, like this. Tuples of keys and values. Do you see? Tuples of keys and values. So I'm fixing it now. Yes, now it works. So I told you about these two now. Now we can also update it. For example, I can say place the name John with the integer 27. Now the name became 27. We can add item. What do you mean? So a second name, it adds a key and value, whose key is second name, and value is Jack. So let's see as at the A now. A here is this. So a the second name and Jack, the key value has been added. We can also remove, for example, remove the key and name. It What does it do when you use pop? It returns the value of the name, but also removes the name and John from the dictionary. Let's see. So here, sorry, I had changed John to 27. It returned 27. Now let's see A. There is no name in it anymore. We can have pop item. What does it do? So let me bring the original A back. So I have A. Pop item name. It returns it was supposed to return name and John as a tuple, the both key and value. Apparently uh, it has changed in this version because the versions of Python usually sometimes change. Doesn't matter. Maybe, oh, I think I should take doesn't matter. It must have changed. We can have clear, a dot clear. What does it do? It clears the dictionary, makes it empty, removes all of the items. We can also delete A, and what does it do? It deletes that from the memory. And then now A is not recognized anymore. Del is short for delete from the memory. Delete the object, the whole object from the memory. Okay, that was dictionary. Now we go to the next data structure, and that's set. So let's see what's going on here. Okay, so set. Set is similar to the tuple. It's immutable or unchangeable. You can't change it. But there is a difference also between set and tuple. And that's in the set, you don't have any duplicates. You don't have any duplicated items. If you have some duplicated, they will be unified. So what do I mean? For example, here, by the way, for defining set, you need accolades. So remember, for list, we had brackets. For tuple, for set, we have accolades. For dictionary, we had accolades, however, with keys and values, right? But For set, we only have accolades. So let's see here. Let me put a breakpoint here. Okay. So here is the set A. So it was 1, 2, 3, 2. 2 was repeated twice, right? But now we have only 1, 2 in it because it can't have any duplicated item. So it has its uses. For example, sometimes you don't care about duplicates, so you can use set, but it doesn't let you change. Of course, you can modify it and I mean take a slice or append to it and put it in another set, similar to what we had in tuple. However, you can't change it in place, right? So you can say, for example, let me say A. So A0 is this. Sorry, for I think sets. Let so yeah, you can't change it. Doesn't matter. So here it's another example. It's another example. A is a set of 10, high, and 11, 12, 13. So what does it mean? This is showing you that the elements of the set shouldn't necessarily be the same type. So here, for example, the first item of the A is a float, then the second item is a string, the third item is a tuple. Uh, Also, you can have these like this, right? Now we can have a for loop over the elements of the set. Like here, we can add an item to this. So we can append to that here, right? And you should note that in set, in contrast to list, the order is not important at all. The order is not it's unordered. That's why I appended 12. So A was this beforehand, right? A was this. However, when I appended or added 12 to that, 12 came here, not at the end. Doesn't matter. The order doesn't matter here. Here also, we use append for list, but add for set. We can have, we can add multiple elements like this. The 22, 13, and 14 in one shot. See? Uh, Also here, as you see, I can't change the elements, the previous elements, but I can append to that. That's one thing. Uh, Here, what does it do? It adds a list and set. So you can add list and set. Let's see what happens. So it added 11, 16, 18, 14, 15, all of them as the elements of the to this set, right? We can remove an item from the list. For example, here, let me think. So here, for example, I want to remove the BMW from this set. Now there's no BMW in it, right? We can have union. There are some functions for it. Union, intersection, difference is disjoint. Let's see an example. So I think it's obvious. Union is the union of two sets. Intersection, intersection of two sets. Difference, difference of two sets is disjoint, whether they are disjointed or not, whether they have overlap or not. So it returns a Boolean. So here, for example, I have two sets A and B, and also I get the union of them. So C should be the union of them. I can have the intersection of them, right? I can also have pop. What is pop? Pop method randomly removes an item from a set and returns the removed item, right? So whenever you use pop in Python, it returns that and also eliminates that from that data structure. So here, for example, c dot pop randomly returns one of them. and then C doesn't have that element in it anymore. Okay, that was set. So I think I covered the all of the data structures, uh, most of the data structures in Python. Now let's move on to other topics. So let me see what we have here. So some small things such as this ASCII. Let's take a look at ASCII. I think these are easy. Let's go over them. Okay, what does this do? By the way, for those of you who are learning, some of you might know these techniques. For example, I want to write something at the start of the in the this place in all of these lines, right? Before character here, before character here, before all here, before all here, right? What can I do? I can say I can click, get Shift and Alt and then drag the cursor. Now I can write things all together. Okay. Uh, However, what if I want to start here, write something here, the same thing here, the same thing here, the same thing here. So now they are not in the same place in the line. Therefore, I can't use a Shift Alt, which was like this, right? So what do I can then use only Alt. Hold Alt, click on this, then here, then here, then here, and then start writing. Okay. This is a good technique when you are coding to do fast coding. Okay. So here I want to add comment. So I say this. Okay, here. Just give me a second. Okay. So, but by the way, there is an ASCII table. Let's take a look at that. Uh, Give me a second. Here is the ASCII table, as you see. So you can go to this asciitable.com and gives you the ASCII table. So every character in computer has some hex code for it, hex or decimal code for it, doesn't matter. So here, for example, small a is its code is 97, small b is 98, or capital A is 67 decimal, I mean. Uh, or for example, at sign is 64, as you see. Uh, and we'll have also codes for number digits. 0 is 48, 1 is 49. So you can see we can also have extended ASCII table for having other characteristics. We can have other languages, Chinese, uh, ASCII code, and these things can have various alphabets and these things. So uh, anyhow, let's go and continue with what we had in the code. So here, I have for example, letter A. Uh, Now I want to get its code, ASCII code. So I can use org. Let me put a breakpoint here. Okay. So ord, maybe short for order, doesn't matter. Ord of A is 97. In ASCII table, if you take a look at that, its code is 97, decimal code. So also I can go the other way around. I get the code, ASCII code, and let it return the ASCII character. So CHR, short for character, of 98 is, sorry, is what? It's B, letter B, small case B. I can have also, I can check whether a character is it is a digit, is it alphabet, is it lowercase, is it uppercase? Let's take a look at that. For example, let's see, be the letter small a. Okay, now let's take a look at this. Is C digit? It returns a boolean false. Why? Because it's not a. Sorry, it's not the digit. The C is letter digit. However, if C was, for example, 3, turn true, right? I mean character 3, right? Uh, Note that it shouldn't be the integer 3. Then I think it will give you an error because is digit is for a character. Okay, so where were we? Okay, let C be the character 3. Is it alphabet? No, it's false. Is it lowercase? I think for this needs to be alphabet. Let C be the letter A, small a. Is it lowercase? Of course, it's true. Sorry, it needs to be C. Yes, it's true. Is it uppercase? Of course, it's false. It's false. And have a string now, a string, or it's a special cases character. We can have either a character or a string of characters. Consider this, for example, S is um, um, hello. Okay. By the way, now this string, I can convert all of it. I can check whether all of its characters are small case or not. Is lower, is false. However, if my H was a small case, then S is lower, is returns true. The other way around, I can do it for upper. Is upper, checks whether all characters are upper the case or not. I can assume I have S hello with capital H, and I can make all of the letters lowercase by this S dot lower, not is lower, lower. Then it returns hello with all small case. I can make it all capital case, S dot upper. I can cast a character C into an integer. For example, if it is digit, assume it is the character 3. C is the character 3. Then I can say int C. It casts the character to the integer like this. But what if C is not a digit? For example, H. I think it will return error, right? It throws error. Okay, that was Ascii. Now let's move on to the next thing. There is one thing which is good to know, and that is any and all. Any and all also are useful. So take a look at this link, Geeks for Geeks. I think it explains it very well. So we have any and all in list and numpy array. Yeah. Okay. Let me put comments here. Yes. Okay. Now I have this code. Let's run it. Yes. Gives me error. Let me just give me a second. Let me put a breakpoint here. Okay. So I have A and I have B. Okay. What is A? A is a list of booleans. B is an array of booleans, right? Okay. Now I can check whether all of the elements of A are true or at least one of them is true. So it's any and all implement the or and in logic. So what is or in logic? It means that at least one of them, if it is true, then it should return true. What is and? Uh, it needs all of its inputs should be true, so it returns true. So by its name, I think it's obvious. Any is or, all is and. Okay, so can you tell me what is any A? Here is false because all of A is false, right? If at least one of the elements of A were true, then any A would return true. What is any B? Again, false. So you can use any and all for both list and numpy. However, there is an important thing. You can say b dot any only for numpy. So see the difference. So we can say any b or b dot any. Both are the same. However, b dot any only works for numpy array. If you use it for list, it will throw error, as I have explained it here. Okay, I think it's obvious, and these are the results of all of these. I have written them here. Let's move on to the next thing. Mm, give me a second. Okay, there is something that I want to tell you about the files. Reading files. What is it? First off, what are these? OS. You don't need to install these. These are uh, uh, these OS glob and these things. These are by default installed in Python. If you install Python, they are available. So OS is short for operating system. OS package, whenever you want to check whether a file exists, a folder exists, list the subfolders, list the folders, list the files in a folder. In these things, you need OS package. What is glob? Glob is for getting the names of the files as a list. So especially when you want to loop over the files in a directory or a folder, you need to use glob. So you can import several packages using comma between them. So rather than saying import OS and then import glob, I can say import OS comma glob. And what does this do? OS chdir means change directory to the folder path that you have as a string, right? Then what do I do with this? For file path in glob.glob, what does this mean? Glob.glob package.glob function. Then I say everything in that folder, everything that is star with the format.png. It returns me the names of all of the files with this format, and then I can print them, for example. Or I can say glob.glob, then the path that I have plus everything that in that path. In that path, everything.png, right? Or I can say all of the files which start with A and have the format PNG, right? Start with A, end with B, but anything in between, .png. Then I have file.open. So I can open the file here, which is a text file. Or I can open it just for reading. R is for reading, in reading mode. I can open it to append to it. A is for appending. W means for writing to the file. F.read, which has opened, when you open the file, now you can read it. F.read reads the whole file, the whole content of the file. Read line only reads one line at a time. So you can use it in a for loop to read line by line. I can go loop through the file line by line in this way. I can also do this with open the file path in the read mode as f, then f dot read lines, then return it to lines, right? Read lines, what does it do? It gives you a list of lines whose the elements of the list are the lines of that text file. Okay. Then I have with open, I can do this as well. I can read it in this way. Then be careful that you need to close the file at the end. Otherwise, it will get that part of the memory and does not release it until I think you shut down your computer. Then you can also read the JSON file. What is JSON? So usually when you have a configuration for your code, you can in industry you can specify the hyperparameters and the configuration in a config.json file or the YAML file. There are two things. So let me write them down. So one of them is JSON file, the other one is the YAML file. These two files, config.json, config.yaml, are the most important files for configuration. So now you can read them like this: import JSON, f equals open data.json, or you can say data equals json.loadf. Okay, what does it do? It loads file f, the JSON file, into a dictionary, and data becomes like a dictionary. Also, you can say json.dump dictionary. So assume you have a dictionary and you want to save it as a JSON file. You can use this. What is this? Here, I can see, I can get the glob. So this is an example for using glob. All of the files in this path with the format text, return them as a list. As I said, you can use this with for loop to go over all of your files here, all of your files in the subdirectory, in that directory. Now, here, if I want to assume I have, I don't care after, so I go up to some directory and I don't care in which subdirectory and of that directory are the files. For example, I go to the drive D and then I go to the folder Benjamin, and inside the Benjamin, I want to return all of the PNG files, and I don't care whether inside it is in Benjamin or it is in a subfolder in Benjamin. For example, in Benjamin, there might be a subfolder named computer, and inside that the subfolder computer, I might have something .png, or inside the Benjamin folder, I have some .png. I want to return all of them. Then I have to do this. So for example, I said doesn't matter. Let me go with the Linux format, home. So Benjamin. Okay, then I don't care about the subfolders since this directory. Then I say **/*, then I should say recursive equals true. Okay, it does that. You need to say the recursive equals true, and also you need to use this format: **/*, /*. Okay, where were we? Here, you can take a look at these links that I had found before they were useful. What is this one? OS list dir is short for list directories. What does it do? It lists all of the subfolders in this path. Looking in the directory this. However, with glob, you can specify a type of file. So this is the difference, right? In glob, you can specify the type, the format. Also here, I can use glob inside a list. So that's one thing in Python. You can implement a for loop as a list. Let me tell you this also, that's important. So here, let me open a new file because I think this is also important. main2.py. Consider this for I in let me think. Yes. What does this program do? So we have a list 3, 4, 5. We have a for loop over this. And then every element is multiplied by 3 and then appended to an empty list B. Then at the end, I will have what? 9, because 3 times 3 is 9. 4 times 3 is 12. Then 5 times 3 is 15. So let's see. Yeah, 9, 12, 15, as I told you. Okay. I can implement it in another way. I can say, rather than this, I can say I, whatever. It's a dummy variable. You can name it anything. I, I times 3 for I in A. As I said, you can name it anything. You can name it Ben. What does it do? For Ben in A, for each element of the A, I named it Ben. And I have a for loop over it, right? For Ben in A times 3, have it as one of the elements of this new list B. So it means that go one by one. 3 times 3, then 4 times 3, then 5 times 3. This is equivalent to this. Okay. Another thing is this. Where were we? Let me think. Okay. What if it becomes a bit more complicated? Assume I say for Ben in 3, let me rename it to I. I think I is easier. Assume I want to say if I is greater than 4, greater than or equal to 4, do this. How can I implement it in this way? Then for this, I need to say for I times 3 for I in A if I is greater than or equal to 4 in this way. So this is equivalent to this. Okay. Another way is this. I say, let me think. Okay. So let's make it more complicated. If I is greater than or equal to 4, do this. Else j equals I. Or I minus 2. What can I do now? How can I convert it in this way? Can I say this? You might be thinking, okay, I can say this. No, it will throw error. It will throw error, as you see. When you have if else, then you have to change the order of if else and bring it before for. So here I have to do this. Did you get it? So when I have only one if should come after for. When I have if and else, they should become before for. Okay, that's one thing. Now this is equivalent to this. Okay. So let's go back to where we were. I was saying, yeah, here, for example, what are we doing now? So I'm saying that glob, this is the list. Now, for F in this, I can do that. Okay. We can also in Python 3, we can use pathlib.path for working with paths. We can also use a strings as paths. This is just however you want to do it. For how do we create a folder if it doesn't exist? This is very useful when you code in industry and projects, because if you, for example, you want to save something in some path, you always need to check whether that path exists or not. Otherwise, you will face error, right? So you can do it either using pathlib. This is the path. Does it exist or not? If not, make the directory. Or you can say import OS. You do it with OS. OS, if not os.path.exists that directory, os.make dirs that directory. By the way, there are two functions, os.mkdir and os.make dirs. So mkdir is make directory. This is make directories. What is the difference? Make directory only can make one subdirectory inside that folder. For example, inside the folder Benjamin, I want to make the folder computer. Then I can do that. However, make directories can make subfolders. So I can, for example, assume whatever we call it. So this is the folder Benjamin. Here, this already exists, this path. And now I want to check whether inside Benjamin there is a folder computer or not. Then I can use mkdir. However, what if this part exists, home and Benjamin? However, inside Benjamin, I want to make a computer, and inside that, I want to make PC, for example. So I need to make two folders inside each other, nested folders. Then if you use mkdir, it will throw error. You need to use make dirs. That's one thing. Okay, here we can also convert pathlib to a string in this way. What are we doing? So we can say pathlib pure Windows path. And these are the techniques that you can use. These are the techniques that you can use for changing pathlib to a string. I myself so far usually use a string, but it's safer for paths to use paths. But if you are lazy and don't want to get too complicated, you can use the strings for paths. Doesn't matter. Okay, here these are for conversion of a string and pathlib to each other. Where were we? Oh, okay. One other thing that I want to let you know is this. The strings, working with the strings. Give me a second. Yes. So here, for example, there are several ways to show the string in Python. So consider this. So for example, I have several. Okay, doesn't matter. I can fix that error. By the way, in programming, you shouldn't be afraid of making mistakes. When you do that, you debug it. Okay, so uh, here I have A, B, and C, some variables. Now, one way to make a string is this. This is called f string. So, for example, I say, see, f. By the way, in Python, you can write strings with quote or double quote. Doesn't matter. But for character, if it is only a character, it needs to be quote. I think it can be double quote for character too, but doesn't matter. For a string, it can be double quote or quote. Doesn't matter. So here we have something named f string. When do we need that? When we want to have a variable inside the string. What do I mean? For example, I say a equals, so far it is a string. However, inside that, now I want to say the value of a. But the value of a might change. Here it is 10. What if later it becomes 11 or something? Then I want to do this. So here, this is f string, which replaces a with its value. I can also make it complicated, such as a to the power of 2, right? I can also, rather than a, it can be anything. It can be, I'm saying that the type is not important, whether it's int, float, whether it's a string, another string, like this, right? Also, here, I can specify how many decimals I want it to have. For example, a plus b, if I do this, a plus b is 13.53673. But I want to have less number of float decimals. Then how can I do that? I can say uh, colon, then 0.2, 0.2 without 0, 0.2 f standing for float. Then it gives me only 2 decimals in the float. Okay. There is another way, which is a bit in previous versions of Python, still existing in Python 3, you can use that, is format. So rather than f string like this, for example, a equals a here, rather than this, I can say move f beforehand and I say format a. Sorry, format, and then here I remove a inside that, inside the accolades. Let me remember. Yeah, I think I'm right. Then I say a. Yes. So these two are equivalent. This f string is equivalent to this. By the way, we can have several parameters. For example, a and b, right? It's equivalent to what? Can you tell me? So I remove these and say format a and b. Okay, that's one thing. Another thing. Again, I can specify the number of float decimals. So I can say here. Give me a second. Float object has no attribute. It must work. I don't know why it's not working. Maybe in some new updates it has changed. Doesn't matter. So I told you the format. There is a third variant of showing the strings in Python, and that's the using what? Can you tell me? I think you have seen it in C, C++, and MATLAB a lot, especially in C. For example, A equals sign, what is it called? Percentage sign D. Okay. Then I say again percentage sign, then A. What is this? This percentage sign, there are several things. Percentage sign D means decimal. It's integer. Percentage S means a string. So percentage F means float. So here, as A is integer, I say percentage D, and now after that I use percentage and I replace percentage D with the value of A. Here, assume my B is float, right? So I can say percentage F, and also I can say my C is high, which is a string. So I can say this. What if I have a character? For example, let D be the character G. Then I can use percentage C, standing for character. Where we use this. So the oldest version, I think, was this, which was borrowed from C to Python. This, and then the format came. Then afterwards, the f string came. So the f string is the newest version of the string in Python. Okay, I said this. Now let's move on to the next topic. Yeah, I think this is also important. What is this? It's filtering from list. So you can take a look at these two websites. These are good. So for removing from list, what should we do? For example, consider this list. We can remove the element 6. Then if you print it, it becomes 3 and 5. We can also remove by index. So here, remove by value. For removing by value, I use remove. And I think if we have several 6s, it removes the first one. Remove by index, you can say del or delete A1, the index 1. So it removes 6, which is in index 1, right? Because we are 0 indexing. And remove, another way for removing by index is pop. You pop it, but maybe you don't use the value of A1. You don't care. So pop, you can care about the value or you don't care. Doesn't matter. And then it removes that. You can remove by condition with if. So what do I mean here? You can say using the same technique that I told you before. So I have this, then I say I for I in A if I is greater than 5. If you want to have an else also, you need to put if and else before 4, right? Remove by condition with if and else. Then as I said, if and else should become before 4. Then we also have remove. Now, so these were removing from list. Now let's move on to removing from array. So I have this A, I make it numpy array. Remove by value in numpy array. What we need to do this. For example, I don't care about, I want to remove 6. I can say A, where A is not equal to 6. And it gives me only 3 and 5. Remove by index. I can say np.delete A and its index. Then it returns this. By the way, these return, right? So be careful. Some of these, for example, delete A1 in list, right? Or remove or pop. No, remove or pop. All of them do it remove in place. So the A itself will. You should be careful about these things. However, some functions such as these, they don't do it in place. So they don't change A, but they return the modified A. So the A doesn't change, you see, but the B is the modified A. Here, we can remove by index using np delete, as I said. Doesn't remove in place. We can remove by index for multiple indices like this, np.delete A and the list of the indices to remove, but it doesn't change in place. Remove by condition, if we have one condition, then we can say A for A greater than or equal to 5. Again, it's not in place. If we have several conditions, then we need to do this. For example, A with where A is greater than or equal to 5 and A is less than 6. Be careful about several things. First off, this is one AND. You shouldn't use two ANDs, and. If you do that, it will throw error. One AND here. Also, you need to have the parentheses. I know it's a bit weird, but you have to have. Otherwise, I think it's either wrong or it will throw error. Again, it's not in place. What is this? It's another example. As I said here, gives error without parentheses. Yes. Also, rather than one AND here, as I said, you shouldn't use two ANDs. Also, you shouldn't use AND because we also have this AND in Python. It should be one AND. Okay. I think the reason is obvious because this AND is AND operator between for logic, right? Whether between booleans, I mean. However, this AND is bitwise AND. Okay. So I told you about the removing or filtering from the list and array. Okay, let's go to other topics. Um, so the next topic that I can cover is I think I covered that. Let's talk about data frame and pandas. So let's take a look at that. First off, for pandas, we need to import pandas and as PD. And here I don't have pandas installed in this package, therefore I have to install that. So what should I do? As I told you, I Google it, conda install pandas. For that, then I found this. So I have to run this for installing the pandas package. I go to my anaconda prompt, which you can't see right now, but I showed you initially. Then I say conda install the Ascii anaconda pandas. It will ask me, are you sure you want to proceed? And I will say yes. So it is installing. So pandas is used for what is data frame? Simply, you can see it as an Excel or CSV file for tables. So it's similar to what you have in Excel or CSV file as a table with several columns and rows. You can see it in Python as a data frame. Okay. So I say we usually import pandas and we name as PD because pandas is too long. So import pandas as PD. And then we say data frame. DF usually stands for data frame. this convention equals pd.dataframe. What does it do? It initializes some data frame. So initialize a data frame is this pd.dataframe with capital D and capital F. Then if I do that, if I print it, it will be an empty data frame. Let me run it so you can see. Sorry, I need to comment this out. Let me run it. Okay, data frame. So as you see, it's columns and index. So index means the rows, columns, and all of them are empty. Now also I can create a data frame in this way. So I have a data, for example, here, a list. Then I can say pd.dataframe data, and I also write the name of the columns. So here is the data, which are the values of the rows. And what column should I name it numbers? If I don't name anything as the columns, then the name of the column will be, I think, 0. Right? That's one thing. What if I have several columns? I think if my data, if I'm not wrong, let me try it. Don't be scared of trying things in programming. You should be brave, and you should also enjoy it. So I have data like this. Let me try it. Let me try casting it to a data frame. Yeah, it became like this. Now, in this case, every row became every row of data frame. And as I have 3 things here, it has 3 columns, 0, 1, 2. I can name the columns here. How? I can say A, maybe, B, Ben. So the columns will be A, B, and Ben, for example. Okay, doesn't matter. Here, let's see this example. Data is this, and data frame. So as you see, the values of the columns and rows don't necessarily need to be the same. So here, for example, column name is string and column age is integers, and these things. We can also have a dictionary like this with keys and values, right? And now I can cast it to a data frame. So as you see, the keys become the column names and the values become the row values in that column. Another way is that, another example is this. This is data, and what is this? Now I'm naming the index. So do you remember the indices by default are zero indexing, starting from 0 and going up, right? However, I can name the indices now like this. The indices are named. Usually we don't name indices. We let them be 0, 1, 2, etc. Here, now I can use a cast the list like this. So I have a list of dictionaries. Here it is in this example, I have a list of dictionaries. Then what happens? Then every key becomes the column name. There is something important in Pandas data frames, which is lock and iLock. What is that? Assume I have, by the way, uh, before talking about lock and iLock, let me tell you one other thing. So we have pd.dataframe, as I told you, right? We also have pd.series. We usually work with data frames, but whenever you get a row or a uh, or a yeah, usually a row, I think, a row of the data frame, it becomes a series. And we usually, I myself don't work with series, so I convert it to data frame. Uh, doesn't matter. Series, you can see it as a row or as a special case of data frame. So let's take a look at that data frame that we had before. Maybe one of them. Maybe give me a second to think. Maybe these two I think is good. So df is this. I want it to have several columns. I think this is better. Yeah, I think this is better. This data frame, consider this. And now I want to tell you about the difference between lock and ilock. Of course, lock is short for location. Okay, so I have df.lock. What can I say? So for when I say lock, then I have to use the names of indices and columns. For example, I say one and name. What should it return? It should return Nick, right? I can say two and age. It returns 14. Uh, however, ilock is exactly a location by index, not index of data frame. Index that as we have in numpy array, for example. So for example, I say 2 and 1. What does it do? So it means that the third row, because it starts with 0, right? And the second column, because again, it's 0 indexing. So it should return 14, right? If I say 2 and 2, it should throw error because there are only 2 columns. Okay, this is the difference of lock and ilock. I think I have explained them here in these comments. Okay, now assume we worked with the data frame and now we want to save it. Especially in industry, we want to save the results as data frame because we need to report them to the manager, right? So what should we do? df, the data frame that we have. By the way, that this df, you can name it anything. You can name it Benjamin, right? That's just a name. df or Benjamin, whatever the name of your data frame is, 2.2 CSV, 2_CSV. And then here we use the path that you have, that you want to save in, plus the name of that .csv, right? Then it saves that. So if you want to save in the same location that you have, the path is dot. It means that the same directory that I am in. And also there are some other functions such as to Excel, I think. Yes, if you want to save it as Excel file. But usually CSV is better. Why? So what is the difference of Excel and CSV? There are several things. First off, Excel, its decimals, I mean the float values, are more accurate. So CSV a bit rounds them a bit, not much. But CSV is much faster to load and to write. Excel is very slow, and also Excel allows having several several sheets in the same file. However, CSV doesn't do that. So we have these. However, also when you are saving, be careful about this. It's better to say index equals false. Why? Because if you don't do that, it will add a column for the indices and it will save the indices. Usually in the index name is not important to us and it is just 0, 1, 2, 3. We don't want to save that. But if the index name is important, then index should be true to be saved in the CSV file. Also, what if we have a CSV file and we want to read it and put it in as a pandas data frame? So we need to do this PD, which is short for the pandas, and we imported that dot read CSV. Then the path and that file, the path is here is a string or a pathlib, right? And then we don't need this. I think index column, we don't need this. Then we read it as a CSV. If it was a Excel, XLSX, I think it was, then we need to say read Excel. Also, we can append to data frame. Let's take a look at this. Append, data frame.append has been deprecated, but previously we had append. Doesn't matter. So one other thing. So why do we need append? For example, we are in a for loop and we want to add the rows one by one. So we do some calculations and add the rows. So for example, let me think. Maybe A is data pd dot data frame. Then we say for I in maybe 1, 2. Then I say they want to add the row. Okay, just one thing. First off, we usually do this. We usually define here. We start with an empty data frame, but we start with what we define the name of the columns usually like this. For example, I say the name and age. Then what do we do here? Just give me a sec. I say, yeah. Let me think. Okay, okay. I say for I in 1 and 2, then I say I dot lock index is 0. Okay. Now I say like this. For example, John and 42. So this code does the thing for us. So it just starts with empty data frame with these columns and then index 0. And then here, by the way, I need to add the sorry, add to the index. Or in other words, I can say index equals index plus 1. In this case, we don't need append. That's why they have deprecated the append function, because you can simply do that using just indexing. Okay, it will increment the index and then you use it with lock, not ilock, with lock, and then it will append the row. That's one thing. Also, you can do it in another way. I will tell you about the for in a few minutes, but for what those of you who already know this, we can do this and use enumerate and say index. And then in this case, we don't need to increment index. It's already been incremented in the for loop. But I will talk about enumerate in a few minutes. Okay, that's one thing. Just two more things about data frame, and data frame will be done. And that's thing. That's, give me a second. That's merge and concat. What is merge? Consider these two. Yeah, let me stop it. Okay, consider these two. Now what happens? I have two data frames, okay, and some of their columns are shared. For example, A, B, C, D. Here it is B, D, E, F. So B and D, for example, are shared, right? Then we can merge them. We can merge these two together like this. pd.merge df1 df2 on key how inner. Let's see how it will be. Let's take a look at this. So for example, data frame 1, how is it looking like? It's like this. What is data frame 2? It's like this. Now, based on by the way, sorry, I said the columns are shared. I apologize. I was wrong. So here, yeah, I have the key column which is shared, not ABC. ABC, these are the values. The key column between them are shared. There might be unshared columns as well, right? And now I can merge these two. What happens? Take a look at this. See what happened? So based on the, I have said here, determined which column on key, okay, based on the key column, how inner. What does it mean? Only consider the intersection of them. So here, for example, here it has B and D in this column. Here also has B and D in this column, and only take these rows, shared rows in the shared columns, and also take the value 1 from this and the value 2 from the other one, and put them together. What happens? You tell me. What happens if I use outer? I think it's obvious. It will use union, but for the parts which we don't have any value, it will put none. Let's take a look. See? Uh, so because we have A, B, C, D, E, F as a union, but for some values we don't have any value and it puts none, not a number, right? Okay, that's merge. Merge is used very useful if you want to if you have two data frames and based on some shared things you want to merge them. And we also have concat. Concat short for concatenation. So take a look at these two, and now I can have this concatenated df. So let's take a look at this. So I have df1. What is df2? Okay. Now, what is the concatenation between them? Of course, it puts df2 at the end of the df1 and it makes a new thing, concatenated df, as you see here. However, you should take a look at this. The indices, we need to usually after concatenation, we reset the indices because 0, 1, 2, again 0, 1, 2. So we say concatenated df dot reset index. Then I say this. We can either say this because we can either say this, okay, or rather than this, I can say concatenate the df dot reset index in place true. So these most of the functions in pandas have the argument in place. If usually by default it is false, it means that whatever you do, it doesn't change the input itself. It will return something. However, sometimes like reset index, I want the input to change. So I say in place equals true. So I don't need to copy it to another thing. It will do it itself. That's one thing. Let's do this and see the result. As you see, the index has become reset. Okay, I already talked about pandas. Now let's move on to the next thing. And what is that? Uh, yes. NumPy list conversions like this. So when we have a list, as I said, we can convert it to NumPy like this using NP array or NP as array. But what about the other way around? What if I have the array and I want to make it list? I can say that list dot to that NumPy array, which is b dot to list. It makes it a list. Or we can say list b. So let me take a look at this. Import NumPy as np. Consider a and b. So B is an array, right? I can say B to list, or I can say list B, which casts B to a list. Yeah. Okay, this is another topic, and I have sort. Sort is important. By the way, I don't care which algorithm, which sorting algorithm does the Python uses. It might be, we have various algorithms for sorting, right? If you are practicing for coding interview, they might ask you to implement a sorting algorithm. If they don't ask you and during your question, you need to sort some list or numpy array, you don't need to implement that. You can use the functions of sorting uh, implemented already by Python. Okay. So here we can sort list or we can sort array. So if we are sorting list, what happens? Here, this is a list. If we use sorted, so there are two things for two functions for list, for sorting list. Because, one of them is sorted and the other one is sort. What is the difference between them? Sorted sorts the list and returns the sorted list, but it is not in place. So it doesn't change the input. As you see examples here. B becomes sorted by A, but A is not modified. I can also sort it in the other way around, right? So reverse, if I said true, by default this is false. Reverse, then it sorts in descending order. By default, it sorts in ascending order. Uh, Now sort. Sort is in place. So sort modifies A and returns nothing. So here also I can have reverse equals true. So that was sorting for list. Now what about sorting for array? So I have these B A, I make it an array, numpy array. Then I can say np.sort. What does it do? It sorts A, but it's not in place. It doesn't modify A, and it returns the sorted array uh, in ascending order. If I want to make it descending order, I can use this at the end of this. Do you see? Colon -1. And what does that do? It reverses the order. So simply let me give me a second. Yes. Okay, let's see some examples like this. Import numpy as np. Now I have A, which is a numpy array. So np.sort A, it sorts it, not in place. A hasn't changed, see? And however, this is ascending for descent. So let me bring it, put it in B. B is the sorted in ascending. I can change, reverse the order. One technique to reverse the order of array is this. Colon -1. It reverses the order. So we can use this technique to make the ascending order converted to descending order. So simply we can say this, and B becomes descending order. So that was one thing. That was sort. But what if the argument of the sort is important? So what do I mean? For example, A is 315, right? It's sorted, its ascending sort becomes 135. Therefore, 1 in the sort becomes index 0. after sorting. After sorting, 3 becomes index 1 and 5 becomes index 2 after sorting. So the arg sort is important for me. Let's take a look. If I do that like this, it becomes, so it says 5. Sorry. When I say arg sort, it means that the first element, so which was, this was, this is A, okay? The first element is 1, which is after sorting becomes the here. So the first element is the well, how should I explain it? I think it's obvious, but how should I explain it in English? So I'm saying that it was 315. Now arg sort, what does it say? It says after sorting, what is the first element? It was the first element before sorting, which is 1. The second element after sorting was the second element after sorting was the first element before sorting, which is 0. Then uh, the third element after sorting, what was that? It was the third element before sorting, which is index 2, right? I think if you think about it, if you take a look at B and A and the NP-arg sort of A, I think you will understand what I'm saying. Just you can pause the video and think about it. So, okay, also NP-arg sort is in ascending order again. We can have the arguments of the sort for descending order by reversing that. Okay, that's one thing. So there, as you see, for list, we don't have arg sort, as at least as much as I know. Therefore, if you have a list and you want to do arg sort, what should you do? You should first convert it to numpy array and then do the np.arg sort. Okay, that was for sort. What else do we have? We have max and mean. I think that is also important in list. So assume A, max of A or mean of A, they return maximum and minimum. I can also see which index is the maximum or minimum. So I can use this. Why? Because this is a technique. Let me tell you. Assume, consider this list. For list, a function named index, a.index. I can say the value, for example, 5. It gives me the index of the value 5. If I have several of them, it will return the first index, the first appearance. Then if I set a index 10, it will throw error because there is no 10 in it. So now using this, I can say return the index of the maximum or the index of the minimum. I can have min and max in numpy array, np.max, np.min, where a is an array, or np.argmax or np.argmin. Okay, that was one thing. What else do we have? Okay, I think now it's a good time to tell you about, first off, let me briefly tell you about, I think already you saw some of the examples, the loops. So there are two important loops in Python, for and while. So for I in, for example, 1, 2, 3, print I or do something, right? Consider the list A, 4, 3, 8. I can say for I in A. Let me call it element. For element in A, then I can print it. What else can I do? What else can I do? Uh, so assume I want to go the other way around, from back to the start. So it will, by the way, it will print 4, then 3, then 8, right? What if I do this? It will print 8, then 3, then 4. The what if, okay, what if I want the indices? So I can say range len a. First off, what is range? So consider this. When I say range 3, it will return some kind of, you can see it kind of something like a list of 0, 1, 2. Okay. Range of 10 means 0, 1, 2 until 9. Okay. So when I say len of a is with 3, right? So range of 3, it means that 0, 1, 2. So it gives me, rather than element, it gives me index. And then what is element? I can say a of index, right? Another, what if I want both element and index at the same time and I don't want to do it in this way? I can say for enumerate, I can use enumerate. And then if I do that, it will return first index and then the element. I can print element and also print index. So enumerate is this. I said that. Also, what else do we have? Okay, while is the other thing. While some condition, maybe for example, less than 2, we can have parentheses or not. This is optional. Then print I, for example, for example, a of I, where we define I to, we initialize it by 0 and then we increase it I, right? This is while and this is for loop. Okay, I already explained this too. What else do we have? So now let's move on to functions. So function is easy. So we say def short for definition or define. Def some function, whatever you want to call it. I'll call it func, for example. Then I can have some inputs, A, B, whatever. Then I can say C equal do some operations such as A, this, and then I return C. Okay, that's one thing. Maybe function, if function doesn't return anything, we can do this, or we can say return. That's it. So I set this to, what else do we have? Okay, now let's talk about generator. I think this link is very good. Python provides a generator to create your own iterator function. A generator is a special type of function which does not return a single value. Instead, it returns an iterator object with a sequence of values. What do I mean by iterator? It means that I want something that whenever I call it, it returns one by one. What do I mean? Assume I have a list. If I return the whole list, then it will be occupied in my memory. But what if I don't want to have the whole list in my memory? So I can say return it element by element wise. Whenever I call it, return me the next element. That's the generator or iterator, whatever you call it. In a generator function, a yield statement is used rather than a return statement. So rather than return, we say yield. The following is a simple generator function. Generator uses yield rather than a return. It can also return a terminate to terminate generating. So let's take a look at the examples. So here, def my generator. So rather than saying return, I say yield. So what does this do? Whenever I call it, the first time it returns 10, the second time it returns 20, the third time it returns 30. This is an example. So I say gen equals my generator. Then I say use next. Next of gen, it returns 10. Then I use next of gen, it returns 20. Then next of gen returns 30. Another example, def fib takes num as input. A and B are initialized, and then I have yield. So you can either do this in order, or you can put this in a for loop. Usually they use yield in a loop. So you do this. The first time it goes inside the for, it sees the yield, it returns that. The next time it continues from where it was. And then it does the next iteration of the for loop and returns that. So it always remembers where it was in the function or in the for loop, whatever you call it. Now I can they usually use generators with in loops, in for loops. What do I mean? For item in fib num, so fib num is called, which is a generator. Inside fib num, I have a for loop. Inside the for loop, I have a yield. So I go and I see this, I return it as one element. This is item. I do my operation in this loop, whatever, in this loop, and then I go to the next iteration of this for loop. Then I go inside this generator. Inside this generator, I remember where I was. So I continue this for loop. I come here and again, I return the next thing. As you see, the item is not the whole thing. So it doesn't occupy the memory much. So it's good for space. So this is and when we can inside this we can use return as well. Whenever you use return rather than yield, what happens? I think I have written yield here with wrong spelling. So whenever I use return rather than yield, what happens? It actually terminates the generator, right? So I think these are some examples and obvious. Okay. In Python 2 previously, when we used range, it returned the whole list, and whenever we use X range, it was a generator. However, they changed it. Now in Python 3, range is a generator. In Python 2, as I said, also for dictionary, items and get items. One of them was generator, one of them was list. But now in Python 3, they made everything generator to be space efficient. Okay, I talked about generator and functions and all of these. Now let's talk about random. Let's go over this very fast. So these are good. This is a good website. You can take a look. This is random package. So import random. Various things you can do for random, for generating random values. So setting random seed. Why do you do that? In the same computer, if you want to run several times and get the same values, if you have some randomness in your functions and whatever, but you want to get the same result by running different times, then you need to set the random seed. This does that for you. float random. This returns a random floating point between 0 and 1. This returns a random floating point between A and B. This returns a random number in Gaussian distribution. Mu is mean and sigma is the standard deviation. Gauss or normal variate. This function, rand_int, returns a random integer in the range between A and B. So this is different from uniform. That was a random float between A and B, but rand_int is an integer between A and B. This a random selected element in the range start and stop, but with a step. Okay. For an example is rand range 0, 3, 2. It's either 0 or 2 because it's a step is 2. This if we want to shuffle a list randomly, so I have a list, I can shuffle it, random.shuffle x. It shuffles that in place. It shuffles it in place. We can have random sampling from list or numpy array. What does it do? So random sampling with replacement, we can use random.sample x, and we can say k equals 2. What does it mean? This is without replacement. Random sampling without replacement. Random.sample x k equals 2. It means that sample 2 samples from x randomly. Of course, k should be less than or equal to the length of x. Random sampling with replacement. So it's also called bootstrapping. So I have x, I can say random.choices x, k equals 5. Then now k can be anything, can be even greater than the length of x. Random element from non-empty list. So I can say random.choice.x. Now for numpy arrays, I can set the random seed by np.random.seed. Float random. So a random numpy array of floats with shape 3, 5, 6, for example, which means 3 rows, 5 columns, and 6 height, for example. From a uniform distribution between 0 and 1. Or you can say, so there are several ways to do that. np.random.rand, np.random.randomSample, np.random.random, np.random.sample. All of them work the same. But as you see, these 3 use the shape with parentheses, but this one doesn't have parentheses. A random float array in range between A and B, but it is float. np.random.uniform with the size or shape. A random numpy array of floats with shapes 3, 6, 5, and a standard from a Gaussian distribution, normal distribution. np.random.randn, which is normal distribution or Gaussian distribution, or a standard normal. A random numpy array of floats with shape 3, 6, 5 from, again, normal distribution, but with A and B. So I can specify. So these were standard normal distribution. This is a normal distribution with a specified mu and sigma. Okay, I can do this. A multivariate Gaussian distribution. So I can have np.random multivariate normal with mean and covariance matrix. So now mean becomes a vector and this covariance becomes a matrix. I can have multivariate Gaussian distribution using another package, which is SciPy. SciPy is a package .stats.multivariate normal. I can have random integers in range between low and high. So I can say np.random.randint. Some examples are these. I can randomly shuffle a numpy array using np.random.shuffle. It is in place. It shuffles it in place. I can have np.random.permutation. It is not in place, okay? This random.permutation is not in place. Also, I can have np.random permutation for multivariate normal. For several rows. So for, well, how can I call it? For numpy array with rows and columns, I can use permutation. Okay, it only permutes along the first index. Okay. What about generating a random sample from a given 1D array? So I can say choice. I can use choice. What does it do? So P is the probabilities of elements. Okay. Should sum to 1 and default is uniform. Replace means determines whether sampling with or without replacement. And if replace is false, size should be smaller than the total number of elements in the array. So it can be used for implementing a roulette wheel in Python. Example is this. You can have probabilities of selection. There are two examples I have provided here. So I already talked about random now. Yes. This is also good to know. Python args are good to know. Args and KW args. So Python has something named star args for a function. When we are not sure about the number of arguments that can be passed to a function, we use that. Python has star args, which allows us to pass the variable number of non-keyword arguments to a function. The arguments are passed as a tuple. What do I mean? Let's see an example. So I don't know how many inputs I have. Might be variable. Then I can say star num, for example. This is anything. You can say star ben, star args, whatever. So now I say for whatever it is, num is a tuple, right? Or you can see it as a list. What doesn't matter. For n in num, why do we call it tuple, by the way? Because I'm not allowed to change it. Then I can say I use the elements and I sum them all, and then I print the sum. For example, I can say adder. I can input 2 inputs, or 4 inputs, or 5 inputs. It works for all of them. It sums them all. Okay. But what is KW args with 2 stars rather than 1 star? It says, what if I want it to be, so Python passes variable length non-keyword argument to a function using args, but we cannot use this to pass keyword argument. What do I mean by keyword? What if the name of the argument is important for me? Then in this case, I use double stars. So for example, def intro double star data, it can be anything, right? Ben, double star Ben, whatever. Then data type of argument, it is a dictionary. It will be a dictionary rather than a tuple now. Then I can, for example, do whatever I want with the with this dictionary. Why is it useful? Because sometimes the order I don't care. The order of the arguments I don't care. I want every argument to have some key. Then the order doesn't. I don't care about the order. For example, this. I can call this, then I say see, what is this? So I have 4 inputs to it, to this function, but I also specify their names, the names of the arguments. Here in this one, I have how many? 1, 2, 3, 4, 5, 6 inputs, and I specify their names. That's the thing. Okay, that was one thing. This is the reason. This is also the reason. So when you have a function, the func a b, you can say print, for example, but something, whatever, a plus b. When you call it, this is for general function, not just for double star kw args. So you can say 3 and 5, but sometimes you can say a equals 3 and b equals 5. If you do that, you can change the order, so you don't care about the order. That's one thing. Also, you should note one thing. When you say, for example, func a equals 3, then for the rest of the arguments, you have to name them. You can't say this. It will give you an error. But you can say the first element, let it be 3. The rest, I name them. It is possible. That's another thing I wanted to let you know. Just one more thing about typing. So by default, this is installed package. You don't need to install it. From typing, import, you can annotate your code, comment it for people to understand your code. You say here, I have, for example, some function, the func, sorry. So assume I want to tell the user that A should be an integer, but B can be float. So I can say this way, A int and B float. Then also I know that the return should be a float. So I can say this. These 3 are just for annotation. Also these are for annotation. I can also say another type of annotation is this. You can say sum the values and return it. Return the sum. You can also be more specific. Say this, args or params, whatever. Then you explain a whatever, an integer. B something doesn't matter. Then returns something. Okay, you can do this. Also, you can have more complicated inputs. What if it is a list? Then you should say list. What list of what? For example, list of integers or list of floats. But you need to import list from typing, list with capital L. You can also have dictionary with capital D. So you can say dict. And for dict, you can say what are the value, the keys. They are a string, but the values can be anything. I say any, so I should import any from typing. Or for example, the values are only integer, then I can say this. Another thing I can say is optional. So assume my input is optional. Optional and but int. So what do I mean? It's you can either leave it so it has a default value, for example, 3, or you can set it, but it needs to be integer, right? You can have optional or optional list of int. Then I can say none. So what do I do? For example, in my code, I say if b is none, sorry, if b is none, I don't know, do something else, it means that it must be list of integer probably. Return sum of b, whatever. Okay, you can do different things with them. Also, so if you don't want to have these annotations, you can also have default values for them. For example, the func one a and b equals 3. What do I mean by this? The default value of b is 3. Return a and b. So now I call this func1. I can say 2 and 5, or I can say func1 2. What does it? These returns 2 plus 5, which is 7, but returns 2 plus 3, which is 5, because b by default is 3, right? One other thing, you can have if name. What does this do? Func. It means that whenever I run this file, so whenever you run the file, it goes inside this if, and it runs whatever you have inside of this. What am I saying here? I'm saying that whenever you run this file .py, go and run the function func. We usually call this function main, whatever. Okay. I already explained this. Let me tell you about the classes, and I think it will be over. I'm a bit tired now. So I have these class. What is object orientation? Just very briefly, I tell you. Have you heard of in philosophy we have something named Plato's theory of forms. Theory of forms by Plato. Do you know that? Plato was a ancient Greek philosopher. He had a theory named theory of forms, which says that everything in this world has a true essence or idea of form in another world. For example, we have different roosters, but there is one true rooster. Or we have different humans. We have one true human, or something like that, in the world of forms. So we can use that analogy in programming languages as well. For example, here we say we have a class, and which is similar to the form, the theory of forms of Plato, and also we have some objects of these objects or instances of the classes. So whenever we make an object, what are we doing? We are making some instance of that class, which has its attributes and its functions. Also, we usually have so we have several attributes and some functions in every class. Attributes, I think it's obvious, some attributes, some variables, and the functions also do something. The functions are also called methods, especially in Java. The functions of the classes are called methods. And also, as I said, what were I saying? So when I make an object, then I have to, or instantiate, when I'm instantiating an object from a class, I have to set its variables. Then also, afterwards, when I set the variables, I can call its functions. Usually whenever I instantiate an object from a class, a default function is called, and that's called constructor, which sets the variables. And the other methods are the simple methods that I can use. So I think already, well, and the classes can inherit from each other. Consider the example of human and mammal and animal. So we have a class animal, we have a class mammal, and we have a class human. Of course, when a class inherits from another class, it takes its functions, but it can have additional functions as well. For example, we have a class animal, the class mammal inherits from class animal, and class human inherits from the class mammal, something like that. For more information on the analogy of Plato's theory of forms and object-oriented programming, you can see our paper. We have a paper. Let me share screen for that. Just give me a second. Yes. So if you go to this paper on philomatics and psychomatics for combining philosophy and psychology with mathematics, here in section we have some examples. So here in section 3.2, I said the relations. So in in section 3.2.1, we have explained Plato's theory of forms, and here in section 3.2.3, relation of Plato's theory of forms with object-oriented programming, we have explained in more detail. Anyways, let's take a look at object-oriented programming in Python. So we have class. We define this in this way. Class A. We usually we name the classes with capital letter. So we start them with capital letter. Class A. We can say either it doesn't inherit from anything. We can say class A, nothing like this, or we can say class A inherits from object, which it means that it inherits from nothing. Doesn't okay. And so here, and then we say, I think, and we can also say it in this way. So there are at least 3 ways to say class A inherits from nothing. This is the instructor, the constructor. Do you remember I said one of the methods or functions is the constructor? So I say def init and self. All of the methods or functions of the class always get self as the first input. Self, comma, and the input, the attribute that I want to set, n, and self.n is the attribute. So the variables are the attributes of the class, and the n here is the input. So n times 10, I put it as the attribute, and then this is the function or method compute that I can call. Here, class B inherits from the class A. I can say super dot init something. What does it mean? When I say super, it means the super class that I'm inheriting from. Call its constructor and set and give n to it. So I can call the functions of the super class as well, including its constructor method. Yes, so this is an example of different classes, class A, class B, and class C. And here I'm calling, so I'm making an object of class A, then I call its compute, then an object of class B, call its compute, and class C and its compute. Let's take a look at that. When I say class A, n is 10. What happens? Self.n becomes 10 times 10, 100. When I say compute, it prints 100, right? The next thing, class B, n is 10. Itself.n becomes 10. Then super.init n. So I call, it's inheriting from A. I call this, so 10 comes here. Self.n becomes 100, right? So self.n first became 10, then became 100. Now it's compute, 100 times 4 becomes 400. C, class C. Super.init n is 10. So here super.init, so it self.n becomes 10 times 10, 100, but then self.n becomes 10. Therefore, when I say compute, it 10 times 4 becomes 40. Okay, this was classes and its inheritance. There is one that I wanted to tell you, and that's the abstract class, and it's this. So we can say we can have a class with abstract method. What does it mean? Because I want to have another class which inherits from that, but I want this class to be kind of a template. This is good for team programming. The manager makes or the leader of the code makes a template, and everyone inherits from that. And then what do we do? Here, abstract method usually does nothing, so we have pass in it. Then every team member, every class implements that abstract method. Okay. And we usually use from ABC, which is abstract class, import ABC and abstract method. We do that. Okay. I hope it was useful. I think I covered most of the important and helpful functions and concepts in Python. I know that sometimes I jumped from one topic to another topic, but I tried my best. I think this is good for you if you watch this to review for the coding interviews and different things, but at least I tried my best. Thank you very much. I hope it was useful.